So another resistance question. The graph below shows how the current I in a filament lamp varies with potential difference across it. And once again this question, define electrical resistance. And once again I'll tell you, it's the potential difference across a component divided by current through a component, or the ratio of the potential difference across the current, across a component, to the current through a component. Right, there's a couple of follow-up questions which I'll answer here looking at the graph. So the first one is, does it follow Ohm's law? And no, it does not, because if it had followed Ohm's law, it would be a straight line. So the answer is no. Next question, which is on the other page, is calculate the resistance R when the potential difference is 2.8 volts. Now, it's very tempting to use gradients and stuff, but do not use gradients. The IB does not like it when you work out resistance from the gradient of a current voltage graph. What the IB want you to do is to take the coordinates. I know, it's not often the IB want you to do it the easy way, but they do. So, if we know that the voltage is 2.8, you find 2.8 on here, which I'm going to do rather badly because it's difficult to draw, here, okay, and then you read the point here, okay, so you've got a voltage of 2.8 and a current of, and careful with units when you're reading units from the axes of graph, here it's easy, okay, there's no times 10 to the power of something, it's just 0.33. So we work out our resistance by just dividing the voltage by the current, which gives us 8.5 ohms. So the next question states that you have two identical filament lamps, like the one in this graph, like that, connected in series with a cell of EMF 6 volts. Okay, using the graph, so you have to use values from the graph. Calculate the total power dissipated. Now it's a current voltage graph, so it's probably wisest to use this relationship, power equals current times voltage. But now what current and what voltage? Well, if 6 volts are being used with two bulbs in series, what each bulb is receiving is 3, because voltage splits. So we've got 3 and 3. Okay, so if you have a look at the current through each bulb, if you have a look at 3 volts, then you can see approximately that the current is 0.35 amps. Okay, so now we have our current 0.35 and our voltage, which is 6. Sorry, so that should be multiplied by 6. Why 6? Because the question, and we'll look at the question in a second, is calculate the total power dissipated in the circuit. So the total power would be the total energy spent on both bulbs. Okay, so when you have 0.35 times 6 would give us 2.1 watts. Here are the questions, but of course we can't do them without the graph in front of us. So yes, we have found if it obeys Hooke's law. We've worked out the resistance when the potential difference is 2.8. We've also worked out the power dissipated. Okay, so this question is done.